I'm Jamie Poholko, one of the customer success managers here at PPO. Today we're in our production facility at our headquarters in Waterloo, Ontario, Canada. This is our Waterfall configuration system. It is currently being used to inspect bacon bits, frozen and ground products, chicken, pork, and beef in the industry today. I'm going to walk you around the machine to give you a little bit of insight into what this machine looks like, what some of the features are, and I'm going to start with the HMI. So the human-machine interface gives the operator lots of feedback about the operation of the machine, the current status of scanning, if it's faulted. We have buttons across the bottom to start the machine, to reset faults and check the safety circuit, and actually set it into sanitation. The machine also has a stack light to give an indication from further away what the status of the system scanning is. In its current state right now, it's not ready to be scanning, but it's ready to start. It can be also read when it's in a faulted state, and it gives that feedback to people that are further away. Below the HMI, we have all of our pneumatics. PPO has done extensive research into what are industry standard and common components. We're using Festo for all of our pneumatics. We're using Allen Bradley for our PLC. We're using ABB for our safety circuit, Powertronics for our VFDs, all things that are industry common, industry standard, and proven to work in the food industry. I'm going to now show you a little bit about some of the safety aspects of the machine. We have a drive disconnect so that when your employees need to go inside the machine, they can flip the switch, turning off the power to the VFDs. It's also a lockout tagout point, so they can make sure that they're the only ones that have control. Your main disconnect is located in the same spot. So let's go inside the machine a little bit, and I'll point out some of the features that exist. The first thing you're going to notice are two big boxes. This is where our spectrometer and our vision cameras are located. They're tightly sealed away from sanitation and any kind of water ingress. We've had very good success in industry already with them, no water ingress at all. There are also hyperspectral lamps that are going to illuminate the product across the entire width of the belt so that we inspect that full belt width of your product. We have one rejection mechanism after the first inspection, and then the product tumbles and falls down onto the second belt and is inspected again, and then there's a second rejection mechanism there. You'll see that the pneumatic cylinders are what we're using to pull back the rejection, and the rejection mechanism is a full pullback, so it's rejecting the full width of the product. You see we have a bunch of sanitation features, one of them being the rollback side product guides. We'll talk a little bit more about the sanitation features on the opposite side because we have a clean in place. There's also belt lifters and other things that we're going to talk about in just a few moments. I'd like to show you what's inside the cabinet on top of your system. We use Ratal keys and seals to ensure that the system stays nice and dry and there's no water ingress. Let's have a look. Inside this side of the cabinet, we have VFDs, we have other low voltage components, our breakers for the system. We also have a UPS lockout tagout point. The system has a UPS in case there's momentary loss of power in the plant or even longer periods of time. It allows the system to stay operational while keeping all of your low voltage things operational while there's no power in the plant, keeping the PLC, computers and HMI powered up, minimizing the startup time when power is restored. On this side, we have our Allen Bradley PLC, we have our breakers, we have relays across the bottom. We also have our ABB safety circuits. These are connected to the HMI and also the enclosure doors. And they're industry standard and are widely used everywhere. We also have connection to the outside world, to the internet. so that the system can upload detections to the cloud for further processing. It also allows PPO access into your machine in case you're having a problem. We can inspect and investigate and help through any kind of issue. Let's go around to the other side of the machine now, and I'll talk about the clean in place features and some of the other features that are on the opposite side of the machine. Follow me. Now that we're on the opposite side of the machine, I want to talk through detection, starting with the in-feed. The in-feed is where your product enters the machine. Bacon bits, fresh and frozen ground products, chicken, beef, pork are all being used today and inspected by PPO systems in North America. The product is going to enter on this side. It's going to flow through in a single layer, because if it's not in a single layer, that's where foreign materials are going to hide. It's going to flow through and hit the first detector module. The detector module is going to inspect the product and detect for foreign materials. If there is a foreign material detected by the system, then it's going to reject at the first rejection mechanism. If there are no foreign materials found, then the product is going to tumble, exposing another side of the product to be inspected by the second detector module. Second detector module is going to inspect that product for foreign materials and create detections, and then reject at the outfeed rejection mechanism. Let's take a closer look at how all of this detection takes place. This is the detector module like we saw on the other side. We use the same Ratal seals and key to access the detector module. This detector module is only serviceable by a PPO technician. There's very sensitive components inside, spectrometer and regular RGB camera. Inside, you can see on the bottom is our spectrometer, and it's sending information up to our computer system that we're going to take a look at in just a few minutes, along with the RGB camera as well. The detector module uses both regular visible light and near infrared light with the spectrometer, and those are used together to detect for foreign materials. You'll notice we have some other clean in place features that we'll come back to in just a little bit. Let's take a look up top and see the computer systems. After looking at the detector module, let's see where all the information that's collected by its components, and where does it go? It goes up here to these computers. There's one for each detector module, and we also have another control computer to manage the traffic between the detector modules and the computers. We need this extra computer to manage this traffic because there's 10 terabytes of information processed every single production day. That information is processed inside of these computers, and decisions are made in a fraction of a second to decide, was there a foreign material and does it need to be rejected? Another couple of components we have. One is the power supply for our hyperspectral lamps. This power supply is 120 volts DC, so that we can maintain a strong and constant signal for our hyperspectral imaging system. The next component is a UPS. In case there are momentary lapses of power inside the plant, the whole machine doesn't go down. This keeps your PLC, HMI, and the computers up and operational, minimizing the amount of time it takes to get back into operation when the power is restored. On the other side of the cabinet, we have a heat exchanger. This heat exchanger is needed because of all of the heat created by the computers, by the detector module, and the hyperspectral lamps. This heat exchanger removes all of the heat, maintaining a really good operating temperature for all of these components and making sure that your system is going to operate at peak performance always. Let's go around on the other side, and I'm going to start up the machine, and we're going to see some detections and rejections like you would see in normal operation. Come with me. We're over here at the HMI, and I'm going to show you how quick and easy it is to start your PPO Smart Imaging System. It's a single button push to start your system. What's going to happen is the system is going to start to come alive. It's going to start the belts running in operation, as we said earlier, in feed, forwarding out to the out feed. The lamps, the hyperspectral lamps are going to turn on so that your detection can happen at both locations. The hyperspectral lamps need a 90-second warm-up time so that the near infrared and all the wavelengths are stabilized and are ready for inspection. You'll see on the stack light, you have not ready for scanning quite yet with your flashing lights, and you'll see visual indicators on the HMI as well. When you first start up and come out of sanitation, your system is not calibrated. The system is going to start a calibration automatically. The calibration arms are going to come down. We'll see this in just a few moments once the lamps have had a chance to warm up. The same procedure is on this machine as is on our Z-config machine. And if you haven't had a chance to look at that video, you can click on the link above. So once the system has had a chance to fully warm up, the calibration arm comes down. What's happening are the cameras are scanning that to get the profile of light that's across the entire belt width. As soon as the calibration is complete, the arms will retract back into their resting position, and it'll begin scanning. You'll get those scanning indicators after calibration is completed by the green light saying solid and the yellow light going away. You'll also get an indicator here on the screen. If the calibration does not pass the first time, you're going to see that the system is going to try again automatically. This is not needing any intervention by your operations or teams. They just can go and do other things while they're waiting for the system to become operational. So calibration usually takes between 30 and 45 seconds per time. It's measuring the light across the entire scan line on both detector modules at the exact same time. Now the calibration is complete, I'd like to demonstrate a detection and rejection event that would happen in normal operation. After seeing a detection and a rejection event, I want to talk about the safety features of the system. So one of them is a e-stop conveniently located at each end of the system that shuts down the machine, both power and pneumatics and the lamps as well. Let's look at some of the sanitation features of the machine on the other side. I'd like to go over a few of the sanitation features of the machine, including belt lifters to expose the underside of the belt. We have them in multiple locations throughout the machine. We also have removable rollers that do not require any tools. You can lift and pull them out, no problem. The side guards roll back to get out of the way of the belt, and in doing that, you can use the belt lifter to lift up the belt and access the underside of the conveyor belt to make sure it's nice and clean. You see that there's piping along here. This is our clean in place system. There are nozzles on each of the belts to clean them off, and you also hard pipe this directly into your sanitation system. So you can run chemicals or hot water through to really loosen up and get the system ready for the sanitation team. One of the final features is the ability to get into the rejection mechanism here at the back on the outfeed side. You can clean out the rollers, you can get into the belting really easily with these access. And there's one on each side. Thank you for joining us on our walk around of PPO's patented Waterfall system. PPO's Waterfall and Z configuration systems are installed in pork, beef, and chicken facilities that are primary harvest, secondary processing, and RTE facilities. And it's ready for yours too. We look forward to working with you.